Good morning, ladies and gentlemen. Welcome to Math 20-1, Chapter 6, Section 1, Angles in Standard Position. Now, here we're talking about trig ratios in the coordinate plane, and we're limiting ourselves to the first quadrant today. Next lesson will be the whole circle, but in the first quadrant, note some new definitions for you. The terminal arm, this rotates around the origin counterclockwise. So we start at the origin, and we rotate counterclockwise up. Now, the initial arm is fixed on the x-axis, so our angle in between is here. I'll call it angle theta. And we have the coordinate point x and y on this line. Okay? Now, redrawing that because it's slightly messy, you'll notice here we get this nice right angle triangle, the radius r, side x, side y. Now, and this is all stuff you're supposed to remember. Pythagorean theorem, x squared plus y squared equals r squared. Now, some people will write on the formula sheet r equals square root of x squared plus y squared. That's just Pythagorean theorem rewritten. If you remember it, great. If you don't remember it, surprise me. Now, tan of theta is opposite over adjacent, which is y over x. Sine of theta is opposite over hypotenuse, y over r. And cos of theta is our adjacent side, the x side, divided by our hypotenuse, r. So this is the newish stuff you have to know and remember. In Math 30, I do not talk about opposite and adjacent for the tangent. I talk about the y and the x sides of the triangle. And notice how this is written on the coordinate plane. So sine is y over r, and cos of theta is x over r. That's the new stuff you have to remember. Okay? So let's do some questions. The point 3, 2 is on the terminal arm of angle theta. What is sine theta, cos theta, and tan theta? Notice I've drawn it, and I've made some effort to make it an accurate drawing. So, we need sine theta, cos theta, tan theta. And I've rewritten the formulas. Sine of theta is y over r. Y is my y-coordinate, 2. Actually, this is 2. This is my x-coordinate, 3. Now I need my radius. Well, rewriting Pythagorean's formula like that, r square root of 3 squared plus 2 squared, which is the square root of 9 plus 4. So r is the square root of 13. Now, I'm going to say this once nicely. In trigonometry, leave it as an exact value, square root of 13. Do not go 3 point whatever as a decimal approximation. I will be unhappy. Okay? Leave it as a radical. So here, sine of theta is y over r, and my y value is 2, and my radius is square root of 13. Okay? Now, my cos of theta is x over r. My x value is 3. My r is root of 13. And finally, my tan of theta is y over x. Now, y is 2 divided by 3. Now notice here I'm asking for the ratios. I've also asked, no, I have not asked for the angle theta. How would I find the angle theta? Well, that's easy enough. First thing you need is Mr. Calculator, Poopy Head. So grab it, turn it on. If you haven't got it, I'm unhappy. Now I need you to turn it on and check something before we go any farther. As I've said repeatedly, Mr. Calculator, the TI series, will go into radian mode. So you always have to double check mode. And yes, this one's in degrees. So, clear. Now, here we did sine of theta is y over r, 2 over square root 13. Theta, angle theta, is sine to the minus 1 of 2 over square root 13. And this is why you don't do rounding off. So go to Mr. Calculator. Inverse sine 2 divided by square root of 13, close bracket, is 33.69, 34 degrees. Now, from my crude drawing, do we agree with that? Yes. I'll call it 33.7 degrees because I can. That's the other reason we do spend a moment making a drawing, so we can check our answers. Now, you guys should have a protractor somewhere. If not, you can always measure if you get stuck, do a nice drawing on graph paper with a pencil and ruler and protractor. You can measure the angles and you can be quite close. which is why quite often on a test, if it was multiple choice, I go 33, 33.5, sorry, 33.1, 33.7, 34.2, something like that. Something close enough that if you tried measuring, you'd be guessing, but you can easily get the exact value if you do the calculation. All right? Now, another one for us to try. The point 5, 12 is on the terminal arm of angle theta. What is sine theta, cos theta, and theta itself? Well, first thing we have to do, draw our coordinate plane. Now, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's something like that's our angle theta. Okay? So, sine theta, cos theta, tan theta, we need our radius again. Now, oh, sorry, close bracket. So, a squared plus b squared equals c squared, or x squared plus y squared equals r squared. I'm showing you two different versions. It's the same formula. Some people learned a squared plus b squared equals c squared and will insist on doing that. I want you to realize that's x squared plus y squared. Do I really care? No. But this can be rearranged as r is the square root of x squared plus y squared. That's a nice shortcut if you can remember it. If you can't, it's just Mr. Pythagorean's theorem again. So r is the square root. My x is 5. Now, that's the square root of 25 plus 144. R is the square root of 169. Now, that happens to be 13. Just so happens to be a perfect square root, or perfect square. Anyway, so there's no decimal approximation here, which makes the numbers a lot easier. So, sine of theta sine is opposite y over r. In this case, that is 12 over 13. Cos of theta is adjacent, or x over r, which is 5 over 13. Now, I was asked you, now this time I do want you to find angle theta. I am going to choose cosine, because I happen to have the pen in my hand, and it's already blue. It doesn't matter. Inverse cos bracket 5 divided by 13, close bracket, enter, 67.38, 67.4 degrees. Now, from my crude drawing, is that reasonable? Yes. Now, for the heck of it, let's do sine also. Just humor me. Inverse sine 12 divided by 13, 67.38, the exact same angle. So you only had to do it one way. Notice I rounded it off to 67.4 because, yeah. And that's normally what I want you to do, usually one decimal place with these calculations. All right? So that is most of this. Well, this is the meat of the lesson. But how can I ask the question? Well, here's one. Here's an interesting version. The terminal arm is in the first quadrant with sine of theta equals 4 over 11. What is cos theta, tan theta, and theta? Okay. Now, first thing I do is draw a picture. Okay, now here I have a problem. Sine of theta, I don't have a coordinate. I have a sine theta. Sine of theta is 4 over 11. Now, what is that ratio? It is always y over r. So I go, I go 1, 2, 3, actually I should 2, 3. I go 4, and this would be 11. Now that's a crude drawing, but you get the idea. So my x is somewhere down here, close to 11, but smaller than that. So for cos of theta, I need x. So how do I solve for that? Well, remember, r is square root of x squared plus y squared, or r squared equals x squared plus y squared. We know r, we know y. Let's solve for x. So r is 11, x we do not know, and y, y is 4. So 121 equals x squared plus 16. Subtract 16 from both sides. X squared is, excuse me, 104, so x is the square root of 104. So far, so good? All right. Now, I'm happy with that. Actually, no, 105, isn't it? My apologies. Can't do this in my head anymore. Getting old. I hate this getting old. I used to be able to do this. Now, I know 105 is not a perfect square. Let me just double check. 11 squared minus 4 squared is 105. Yes. Now, can I factor 105? Well, it's 5 divided by 5 is 21 times 5. So it's 3 times 5 times 7. No, I can't factor it or simplify it. Anyway, so cos of theta, my x value is square root of 105 divided by my radius, which is 11. Now note, square root of 105 is like 10, which is smaller than 11, which makes sense because this shorter side has to be shorter than the hypotenuse. Okay, so I asked to find, tan theta. Tan of theta is y over x, which is 4 divided by square root of 105. Now, some of you guys are going by now, but Mr. Sutton, you talked about not having a square root in the denominator. Yes, with radicals. With trig, we leave it there, because quite often we use it in another calculation and we can get it to cancel out. So right now, I'm happy for you to leave it as 4 divided by square root of 105. Okay? And, theta. Since I happen to have the blue pen in my hand, theta, 10 to the minus 1 of 4 over square root of 105. Inverse tan 4 divided by, where's the square button? Square root 105, close bracket, 21.3 degrees. Yes, from my crude drawing, I believe that. That's a reasonable number. Okay? So that's how this goes. How can I be a poopy head? Well, typical poopy head questions right here. The point xy is on a line that makes an angle of 38 degrees with the x-axis and is 11 centimeters from the origin. What are the coordinates? Well, draw a diagram. Xy makes on a line that makes an angle of 38. So 38 is, no, that's not quite 38. 38 is probably more like that. Yes, a little less than 45. And this is 11, this is x comma y. So here we have to figure out our y and our x. Okay, so what are the coordinates? Well, I'm arbitrarily going to do the y first, or the opposite side. So sine of theta is y over r. So sine of 38 degrees equals my y value divided by my radius 11. Now, earlier I talked about rewriting this equation. So multiply both sides. So y equals sine theta times r. That's actually an easier way to do it. I should be doing it that way. I'm just, oh God, getting old. 11 sine 38 degrees. So grab Mr. Calculator. 11, my apologies, 11 times sine 38, close bracket, 6.77. Now, from my crude drawing, yes, that is reasonable. Now, cos of theta is x over r, so I should rewrite that as x equals cos theta times r. That's actually a nicer way to do it. So my x side is cos of 38 degrees times my radius of 11. Try that out. Cos 38 close bracket times 11 8.668, call that 8.7. Sorry, I'm on 2 decimal, 8.67, my bad. Should round it off to 1 decimal place, but I'm less lazy than I normally am. Okay, so the coordinates are 8.67, comma 6.77. Now, as I said, I normally round this off to 1 decimal place, so I'm quite happy with 8.7 and 6.8. And once you solve for y, could you have used Pythagorean theorem to find x? Yes. Assuming you didn't make a boo-boo calculating y, that's a perfectly reasonable way to do it. But since we're doing trig, I'd rather do sine, cosine, tangent. Now, yes, last question. You quad 7 kilometers, 34 degrees north of east. How far north and east have you gone? Okay. Those of you who did physics 20 are going north of east. Okay, so you go east, then you swing north to make an angle of 34 degrees. So that's a smaller angle, so that would be 34 degrees, and that's 7 kilometers. So this would be your breakdown. Where exactly are you, and how far, I know, change color. How far east and north do you have to go, or your x and y coordinates? Exact same question, which you did before. Now I'm going to pause the recording. We'll come back and compare answers, okay? Okay, when I did it, you got sine of theta is y over r, or y equals sine theta times r. Y equals sine 34 degrees times 7. I got 3.91 kilometers. That's going north. And your x value, cos of theta is x over r. X equals cos theta times r, or 34 degrees times 7, 5.8 kilometers east. Okay, from my crude drawing, that seems reasonable. Any questions so far? Well, if you have questions, shoot me an email. Otherwise, I'll see you in class tomorrow. Work on the check your understanding questions. Good luck. Stay safe.